Second half of section 7.6 is solving logarithmic equations. Obviously, logarithmic equations are going to be equations that have logarithms in them. Let's see. So our basic statement is going to be log base b of x equals log base b of y if and only if x equals y. That simply says if the base of your log are identical and you know that these logs are equivalent, then the number that you're taking the log of must also be equivalent. And that makes our solving quite simple, because if we have a problem such as this where we have the log of 4 of some amount and these logs are equivalent, well, the base of the log is exactly the same, so therefore these must be the same. 2x plus 8 must be equal to 6x minus 12, and that is a simple problem to solve. It goes back to Algebra 1 days, so you can even do both in the same step. I'm going to keep my x's positive, add 12 to both sides, and subtract 2x from both sides. 8 and 12 are 20, equals 6 minus 2 is 4x. Divide both sides by 4, so x must equal 5. Easy sneezy. Okay, so what happens though if you've got an equation with a log and you don't have two logs equal and they don't have the same bases? What if we have log base 7 of 3x minus 2 equal to 2? Well, what we can do is this. We're going to learn a new word, exponentiate. How fun is that? So remember, we can do, as long as we do the same thing to both sides, we can do whatever we want to an equation. And you've added, subtracted, multiplied, and divided. You can also exponentiate both sides. So pick a base and make what you've got the equation, because remember we learned in the last part of the first part of this section that if the bases are the same, then the exponents must be the same. So if we can give these whatever base we want, and then the exponents will stay the same, and these we already know are the same. So because this is log of base 7, we want a base, or we want to exponentiate by 7. So we're going to exponentiate both sides of this equation by the same base, by 7. So now if we have 7 to the exponent of log base 7, 3x minus 2, this simplifies down to just 3x minus 2. All right, because we have the same base as the base of our log. And remember, with our inverse functions, we learned that that's equivalent to just the exponent. So now 3x minus 2 equals 7 squared, which is 49. And now we solve it. Add 2 to both sides. 3x equals 51. Divide by 3. So x equals 17. Done. Easy, easy, easy. All right. Make sure when you're working with these logarithmic equations that you check for extraneous solutions. All right. So sometimes you're going to get something that looks like an answer that isn't actually an answer. So let's solve this one, and we're going to start with, well, we can consolidate this and make it a little more concise. If you remember, if we add these two logs that have the same bases, this is the same as multiplying what the log is of. So log base 6 of 3x times x minus 4 equals 2. Right? Okay, and then I believe what I want to do, what did I do last time? Oh yeah, here we go. So I believe what we would like to do now is just what we did before. So now we've got a log on one side and not on the other. So let's exponentiate and get rid of that log. So we're going to exponentiate this log, and so we have to exponentiate the other side. So now, because we exponentiated, all this goes away, and so we just have this part of the log becomes what we're working with. So let's multiply the 3x through this at the same time. Can we do both of those steps at the same time, because I'm running out of room? So multiply that through. So 3x squared minus 12x equals 6 squared is 36. So now we're going to subtract 36 from both sides. 3x squared minus 12x minus 36 equals 0. We can pull out a 3 and have x squared minus 4x minus 12 equals 0. And I'm going to come look. You keep going. I'm going to look and see. I might need to make you a little bit seasick because I have more space, but you can't see it. So here we go. That'll give me plenty more room. Let's finish this problem this way. Okay, so did you factor this trinomial yet? So keep the 3, and when we factor this, x and x, negative sign, so it's a plus and a minus, and we want to subtract to be 4, so we're going to have 6 and, 6 and 2. 6 times 2 is 12, and then negative 2, positive 6. Guess what? I've got positive 4x, so what I want to do is switch my signs. So now I have negative 6x plus 2x gives me my negative 4x. So there's my two binomials. And now when we're solving, obviously 3 can't be equal to 0. So we're going to solve for x here. So x equals positive 6 or x equals negative 2. Those are my two solutions here when I solve. So now I'm going to, and what I'm going to do is I'm going to erase and come up here for my check because we need to check for the extraneous solutions, and I think I really might be running out of room down there. So instead of making you seasick again, we'll make some more space right up here. Okay, so let's take the 6 and put it back in. So we're going to take 6 and put it back in the original for x. So log base 6 of 3 times 6 is 18 plus log of 6, or I'm sorry, log base 6 of 6 minus 4 is 2. And all of that we want to equal 2. So we're going to take 18 times 2 is 36. Log base 6 of 36 equals 2. Is that true? 6 squared equals 36. Is that true? Yes, it is. 6 squared does equal 36. So we're good to go. All right. So then let's put it, so x equals 6 is one of our solutions. Now let's put in the x equals negative 2. So when we put that in, we're going to say log base 6 of 3 times negative 2 is negative 6, and plus log base 6. And actually, you know what? You can even stop there because log of a negative number is undefined. And because the log of a negative number is undefined, negative 2 is going to be an extraneous solution, so x equals 6 is your only solution. And were you able to see any of that? I just realized I moved it up. Oh, good. Oh, okay, mostly of it. Oh, man. There we go. I tried to make life easier and I made it harder. Sorry about that. All right. So if you put it back in, if you put your solution back in and you end up with a negative, you're taking the log of a negative number, then it's extraneous and you can't use that. So x equals 6 is our only solution for this problem. All right, last one. Let's do a word problem. And while you're looking at the word problem, I'm going to once again make you seasick and move this around. So the population of deer in a forest is represented by this equation. P equals 50 plus 200 times the natural log of t plus 1, where t is the time in years from the present. So how many years from now? So we want to know in how many years will the deer population be 500. So once again, in this case, a lot of times with the exponential or logarithmic equations, they have to give you the equation. All right, that's just part of the deal. So it makes it really simple for solving because all you have to do is plug in numbers and then be able to solve it, right? So we want the population to be 500, so let's put in 500 for the population. So when will it be 500? And the 50 stays the same, plus 200 stays the same, times the natural log of And the t is what we want to know, plus 1. So the t is the only unknown here. So let's just solve for it. So step 1 is going to be to subtract 50. So 450 equals 200 times the natural log of t plus 1. And then divide. So up until the last step, this is really just simple algebra that you've done before. So divide by the 200 to get the log by itself. And I actually put that into my calculator already. You can reduce the zeros. I took 45 divided by 20, and I got 2.25 equals the natural log of t plus 1. And now we want to exponentiate because we have a log. Don't forget, ln means natural log, and that simply means the log base e. So if this is log base e, then I'm going to exponentiate by e. And when I do this, log this e to the log base e power makes this side equal to just t plus 1, which makes our lives much easier. So then e to the 2.25 power, what you're going to do is simply put that into your calculator. So you'll press the E button, and then if you have a scientific calculator, you'll press the E and then caret 2.25 equals. If you don't, you'll still press E, and then you'll take it to, I think it's x to the n power or y to the x power. So it's the exponent key. So you'll press E first because it is a constant, and then press your exponent button and then the 2.25. And when you do that, you should end up with 9.49. And now simply solve for t, subtract 1. So 8.49, or you can round it to about 8.5 years. So it is approximately 8.5 years. So the population of deer in the forest will be 500 in about 8.5 years. All right, this one is fairly simple once you get in mind what you can and can't do, as long as you do the same thing to both sides. Take advantage of that exponentiating. If you've got the same bases, remember that your logs are equal. So you can just take that base part away, the log base part away, and just set your the numbers of your logs equal to each other. So I will see you next time. And yeah, if it's not clear, see me in class and we'll talk. All right.